Right, in this video, I'm going to do the basics of measures of dispersion. One of them is super straightforward. The other one is much, much more difficult. Okay. All right, so first I have a question here, number one, where I want you to just get the mean of the data set. Okay. So that's the one where you add up all the data values. So we're going to add them all up. All right, so that's 11, 18, 26, 35. And then we're going to take that and divide by the number of data values, and we wind up with 7. So that's the mean that we're calculating right there. All right, now that data set had numbers 5, 6, 7, 8, and 9. All right, let's look over here at data set B and calculate the mean. So very different feeling data set. 1 plus 2 plus 7, and then 12 and 13. All that added up is also equal to 35. So the mean, since there's just 5 data values, is also going to be 7. But those two data sets have a very different feel to them. I mean, think about playing golf. When you play golf, typically for a hole of golf, the par might be 3, 4, or 5, something like that. So here, you might think about a golfer's scores. They're kind of close together. Where over here, one time they got a hole in one time it took them 13 shots, right? So there's a lot of like variability in how they did on these golf holes, okay? So you need something besides the mean, something besides a measure of central tendency to try to describe a data set. Otherwise, you can't really distinguish data set A from data set B just using the mean. Okay? So data values in set A are all so close together. In B, they're further apart. That characteristics is known as the dispersion or spread of the data set. Okay? So there's two measures that we're going to look at. One of them's called the range, and the other one's called the standard deviation. The range is very straightforward. The range of the data set is found by just taking the greatest value in the data set minus the least value, period. So if I want the range for data set A, I'm just going to do 9 minus 5 and get 4. And when I do the range for data set B, the highest was 13. When I take away 1, it was 12. So the fact that 12 is so much bigger than 4 would give you the sense that that data set, the data values are much more spread apart. Okay, so the idea is if you didn't know what the data set was, if I told you their means were both 7, but that the range on data set A was 4 and the range on B was 12, you would have a sense of what that data set looks like. Not the exact values, but you would know that the data values must be further spread apart. All right, now, another common measure of dispersion is called the standard deviation. Okay. So what you're doing there is you're looking at how far an individual data value deviates from the mean. So it's kind of like you look at how far each data value deviates, or how far from the mean is each data value, and then it kind of gives you an average of those deviations. Okay, so I want to back up and provide a little bit of a notation that I haven't mentioned yet. We've talked about the mean, but a common notation for the mean is to use X bar for the mean. That's what that bar over the top. And then you can actually describe the formula for it by using something we're going to see in a moment in the formula for standard deviation. There's a symbol that looks like this that just means add up the stuff. Okay? It means to sum, to add up things. So you can talk about the mean, the formula for the mean being add up all the x's, all the data values, and then once you've done that, divide by the number of data values. Okay, so that's the number of data values. So that's a formula for the mean. I wanted to do that just to introduce this symbol right here. Just means add stuff up. Okay, so we're going to wind up doing the standard deviation of a data set, and then I'm going to do it, and then you're going to stop the video and you're going to try it on another data set and then check yourself. So you'll never have to memorize the formula, but you'll need to know the steps. But the formula will be given to you, and it actually tells you the steps if you can think a little bit about order of operations, about PEMDAS. So I want you to look at the formula while I talk through the steps for this process. Okay? So when you're looking at this, we've got this big square root, okay? And then this thing that means to add everything up. And then we have x minus x bar, so we have data value minus the mean. We have the squaring, we have n minus 1. We have all that to think about. The little s stands for standard deviation. So if you think of the steps really come from PEMDAS, order of operations you would follow. So if I put a data value in here for x, okay, first thing I'm going to do is subtract the mean from it. So that means I'm going to need to get the mean of the numbers, and then I'm going to find the deviations from the mean. That's what the x, taking the data value and subtracting the mean, is doing. Right? And I did that first because it was inside parentheses, and PEMDAS tells you to do that. Right? Then the next thing you would do would be to handle the exponent because of the e. And so that's why we're going to take all those deviations and square them. Okay? And then this says find the sum of all of those. So that means you're going to add up all of those. That's what this does. You're adding up all of those squared deviations. And then the formula has a square root still, but we don't do that next because that square root goes all the way over everything. We would have to divide by n minus 1 first. Okay, and you do that when we have a sample, which we're going to always assume we have. So you're going to take what you just found in the previous step, and you're going to divide by 1 less than the data values. And then after you've done all of that, you take the square root of that. Okay? So that's why the steps are what they are. The formula kind of tells you that. So get used to where you can think PEMDAS and remind yourself of what the steps are going to be. Okay? All right, so I'm going to stop the video so that the video is not real long, and I'll do the actual standard deviation in the next one.